Hello, students. Welcome to Concept 2 on application of the special product. In this lesson, we'll be diving into some powerful tools in mathematics that allow us to simplify and solve complex algebraic expressions more efficiently. First off, let's take a moment to understand why special products are so important. These are mathematical formulas that help us expand or factor expressions quickly, saving us a lot of time in calculations. For example, we will be working with identities like the square of a binomial, the product of the sum and difference of two terms, and others that follow a set pattern. We'll start with a fundamental concept, binomial expansion. You might recall that when we square an expression like a plus b, we apply the formula a plus b squared equals a squared plus 2ab plus b squared. But this is just the tip of the iceberg. We will explore how these rules can be used to simplify larger algebraic expressions, making them easier to solve. Throughout this lesson, I will guide you step by step, explaining each formula and its application with examples. So, let's begin this exciting journey into the world of special products. Get ready to become a master at simplifying algebraic expressions. Stay tuned for some hands-on practice with these concepts. Let's go! Have you ever come across expressions like a plus b whole squared and wondered why they always expand the same way? That's the beauty of algebraic identities. So let's dive into the square of a binomial. To expand a plus b whole squared, we apply the identity a plus b whole squared equals a squared plus 2ab plus b squared. This means you square the first term, then add twice the product of the two terms, and finally add the square of the second term. For example, x plus 5 whole squared equals x squared plus 10x plus 25. Now, what happens when we subtract instead of add? For a minus b whole squared, the identity becomes a minus b whole squared equals a squared minus 2ab plus b squared. Let's see this with another example. 3x minus 2 whole squared equals 9x squared minus 12x plus 4. So, expanding these binomials gives us the full expression, making calculations smoother, especially when dealing with more complex algebraic problems. And that's how the square of a binomial makes algebra predictable and powerful. Let's now look at a different kind of special product, the difference of squares. This one's really useful in simplifying expressions like open parenthesis, a plus b close parenthesis times, open parenthesis, a minus b close parenthesis. The formula here is a plus b times a minus b equals a squared minus b squared. For example, if we need to expand, x plus 4 times x minus 4, using the formula gives x plus 4 times x minus 4 equals x squared minus 16. As you can see, we end up with a simple difference of squares, which is far quicker than multiplying out all the terms. This is why the difference of squares formula is so handy. Now let's tackle a more complex expansion. What happens when we have three terms? We need to expand a plus b plus c squared. The formula is a little longer but still very manageable. A plus b plus c squared equals a squared plus b squared plus c squared plus 2 times a times b plus 2 times a times c plus 2 times b times c. Let's take x plus y plus 2 squared. Using the formula x plus y plus 2. Squared equals x squared plus y squared plus 2 squared plus 2 times x times y plus 4 times x plus 4 times y. This method works for any trinomial, breaking it down into simpler terms. Expanding trinomials becomes easy once we understand the pattern. Let's now explore how to expand a binomial with coefficients using a special product formula. We start with the formula open bracket a plus b close bracket squared equals a squared plus 2ab plus b squared. This formula helps us break down binomials in a simple and organized way. Now, Let's apply it to the expression open bracket to a plus 3b close bracket squared. First, we square each term separately to a squared equals 4a squared and 3b squared equals 9b squared. Next, we calculate the cross product. We multiply 2 times to a times 3b, which gives us 12ab. Putting it all together, we get the final expanded form, open bracket to a plus 3b close bracket squared equals 4a squared plus 12ab plus 9b squared. This demonstrates how special product formulas simplify the process of expanding binomials. When working with more complicated algebraic expressions, special product formulas still come in handy. These formulas can be applied to expressions that include coefficients or multiple variables. Take this example, to a plus 3b whole squared expands to 4a squared plus 12ab plus 9b squared. Similarly, for expressions like x plus y whole squared, we use the same identity and get x squared plus 2xy plus y squared. These kinds of expansions are especially useful when dealing with a mix of variables and constants. By mastering special product formulas, we gain the ability to simplify complex expressions, a skill that's essential for solving higher-level algebra and even calculus problems. Alright, students, let's wrap things up with a quick recap. We've seen how special product formulas are incredibly powerful tools in expanding binomials and simplifying expressions. These formulas are at the heart of many algebraic tasks, making things much easier to handle. We've covered the key concepts, like expanding the square of a binomial, working with the difference of squares, and much more. But remember, the real secret to mastering these formulas lies in practicing them in various contexts. The more you apply them, the more comfortable and confident you'll become. These formulas also form the very foundation of many algebraic operations, playing a crucial role in solving equations and simplifying complex expressions. And I hope by now, you clearly understand the importance of these special products and how they make complex mathematical tasks more manageable and less daunting.